we use an activation function in a neural networks. So as you might have seen in the previous video, in a neural network where we have these nodes, let's consider for this example we have a single layer of neural network. We have these inputs and we have these outputs, and in between we have hidden layers. Now what happens within this kind of a network is we take the input from the input node. Let's consider for in this example, as we can see over here is this, we take this input and again we take the input from the second node and give it to the first hidden layer. We do the same stuff with the second one. What happens is we add this value, let's consider x1 with some weight w11, so, and with the second one x2 w12. So what we do is we take x1 w11 plus x2, this goes to this first node w12, and then we pass it, we take the addition, the value that we get, suppose we get y, we pass this value to an activation function, so we represent this with psi y. Now what happens with this activation function is it adds nonlinearity to it. Now you might be wondering what's the use of an activation function in a neural network. That's what we are going to talk about. So let's consider an example before we go deep into neural network understanding. Let's consider what a polynomial is. So we have, when we say x raised to 1, this is a 1 degree polynomial. X raised to 2 is a 2 degree polynomial. Now if we see a graphical representation, x raised to 1 will have a graph like this that passes through the center. X raised to 2 will have a graph that goes in this manner, and if we go to a higher degree polynomial, let's consider x raised to 3, its graph will go somewhat like this. Now the main reason why we use an activation function is adding nonlinearity. If you consider the first example, this is basically a linear function. So what a linear function does is, when we take a value, a linear function, in a linear function, suppose I have a linear function that represents 200x. What does this mean is when for every single value that is increase in x, if we increase an x by 1, so what we get is 201. So our y-axis will increase by 200. So if this is 200 and if we take the second as 400, so for every increase in the value of x, 1, it will be 200, and then when we go above at x is equal to 2, we get a value of 400. So this is basically a linear function. But the problem with this linear function is, if we have our linear function that goes in this that has a line in this manner that goes from here to here. My pen is not working. And we have 2 points. Now we have to classify this is depending upon, if let's consider an email, if that email is spam or not spam. Suppose we have the spam, we have 2 points on this 2-dimensional area. The spam mails are represented by this 3 dots, let's consider it, and the emails that are not spam are represented by these 3 dots. Now if we want to classify this function, if we want basically a plane and we want to classify every single points that are in this section as not spam and every single mail that is in this section as spam, we cannot classify this kind of a scenario in this form because we have these points arranged in this manner. So suppose if we even take a line from here, it won't classify it, we still have this mail misclassified, and in the same way if we have a line passing it from this area, we still have basically this line misclassified. So for a function to fit in this kind of an example, the best way is to take a higher degree polynomial. what does a higher degree polynomial do? So in this case, if we have x square and we have to classify the males as spam and not spam, so if we have these 3 points of spam and we have these green points as not spam, now if we have to classify this part as spam and not spam, how will we do is basically simple. Now, as I've shown you before, what does an x square polynomial represent in graph is a curve like this. So if we try to fit in a second degree polynomial over here, we can easily fit in this area. So now, as you can see, we can classify the males that are in this region as spam and all the males that are in this area as not spam. Now this function, this classification was practically impossible if we use the linear function. So this is the main reason why we use activation function to classify the problem in a much more better way. I'll show you some of the slides. So in this slide, what I've shown is we have over here 1 degree polynomial, that is a line that's represented over here, and a second degree, this is a linear function. We want to classify these points, but we cannot classify it because it's a 1 degree polynomial linear function. When we use an activation function in a neural network, we add this higher degree polynomials, and then what happens is we can fit in any data in any practical way with using much higher degree polynomials, so that we can fit in the data. So over here, as you can see, this is not spam and this is spam, and we can fit this data much more correctly. So here just I've written some data about it. So without an activation function, linear functions cannot fit data perfectly, as we can see over here, and with an activation function we can fit the data perfectly. So in this, on my website, I've taken an example of a person if you want to classify if he's dressed well and if he's not. So if we have certain points which represent suppose the way he has dressed, depending on his clothes, depending upon his shoes and hairs, if we want to classify it based on that, if he has dressed properly or not, we can easily fit it with using an activation function, that is a higher degree polynomial, in which we can fit the data much more perfectly. So this is all for today. If you did like my video, do share and subscribe to it, and you can visit my website raqeeb.in, where I write in a much more detailed way, and I update my topics first on my website, and then I make a video about it, so you will be updated much more quickly about it. Thanks for watching.